Focus plus context screens combine two or more displays with different resolutions into a single continuous display plane. The term continuous means that display objects that are moved across display regions preserve size and shape, although their resolution changes. There are two different ways of looking at focus plus context screens. The first way is to consider them normal, monitor-size displays that are enhanced with additional low-res display space in the periphery. The other way is to consider them large, low-res displays that are enhanced with a high-res region in the center, very much like a magic lens. Focus plus context screens can be set up easily in almost any office setting with inexpensive, off-the-shelf components. Here is one possible setup that we installed in an office at Xerox PARC. A regular PC workspace with a flat display is augmented by adding a customized projection screen and a projector. The projection screen, primarily a large piece of foam core, is placed on the user's desktop. A hole large enough to accommodate the entire flat panel display allows the flat panel to be embedded into the projection screen. The projector fits conveniently in the space behind the user, which makes this installation very space efficient. To cover the gaps between the two display areas, a paper mask of appropriate size is used to extend the projection screen across the borders of the focus screen, thereby creating a seamless display area. To prevent the projector from causing reflections on the flat panel monitor, a simple program is used to create a black window. After moving the window to the desired position, the user hits the freeze button, which removes all window decorations and leaves the window entirely black. Placing the black window completes the setup, and we are ready to run applications on it.
Hello, this is Patrick.
Hello, Patrick. It's Vic. How are you doing?
Pretty well. How are you?
I just wanted to make sure all the plans for our customer meeting next week here in London are in order. How's the presentation coming along?
It's just about done. I was putting the final touches on it.
I wanted to check you had the exact dimensions of the new robot modules. It's critical that you include the specifications of version 2.
You know, come to think of it, I did have a question about the quick release that connects the modules. Do you have time to explain this now?
I have to run off to a meeting right now. Call me back on the video conference line in an hour and I'll have the part so we can discuss it then.
Okay, then call you later.
Patrick is pulling together the material for the meeting. His Focus Plus context screen allows him to see large images and drawings in their entirety while reviewing or modifying them. The context region provides additional space that allows him to get an overview of the available material and to compare individual documents. Next, Patrick plans his trip to London. He goes to a website to book the flight and to get a list of available hotels. He is unable to decide which hotel to reserve and chooses to base his decision on the proximity of the hotels to the site of the meeting. He uses a map of downtown London to get an overview of the locations of available hotels. At first, he thinks that the hotel located northeast of the customer's site would be closest, but examination of the map and the focus view reveals that there are no bridges across the Thames in that area. The closest possibility for crossing the river, a tunnel located north of the customer's site, would mean quite a detour. Patrick therefore decides to go for the other hotel located west of the customer's site. Being located right in the center of London, this place seems more attractive anyway.
Victoria, can you hear me?
Yes, I can. Can you see me?
Yes, no problem. Okay, so here's the current standings. I got the slides done. I found some stuff that we can reuse for the poster, and I got the circuits printed out. The only part that I have not yet covered is the quick release. You guys changed it in the new version, did you?
Right. The new one is pretty tricky. We're now using a 12th of a turn bayonet. I've got one right here. Do you want to take a look?
Yeah, please go ahead.
Okay, so I'm first going to show you how to unlock it. So what you do is you grab it like this, and then you,
could you lower
twist
this
the
a bit?
module clockwise.
Oh, thank you. Excellent. Oh, I see.
So,
oh, that's cool.
what's nice about this one is that you can connect it on all four sides and at two different angles.
Oh, this is really cool. Okay, I'll add this to the slides, and we're basically all set.
Okay, I'm also going to email you the documentation that I've prepared. This is for the meeting, and section 2 has something about the bayonets connectors in there.
Okay, I'll check this out.
Okay, anything else?
Not from my side.
All right, till Thursday then.
Okay, see you on Thursday. Bye.
Bye.
When applied to 3D simulation or games, focus plus context screens not only increase the level of immersion, but also fit more information into the user's field of view. The focus region offers high detail and allows seeing objects that are right in front of the user. At the same time, the context area is perceived through peripheral vision. The fact that the context area is low resolution does not affect the user's experience, because the human retina is basically restricted to the perception of motion in that area. Note that the crosshair never moves. Instead of moving his eyes to objects of interest, the user continuously pans objects of interest into the crosshair region. Throughout this demo scenario, the user was working with large visual objects, such as drawings, photographs, maps, video transmissions, and 3D worlds. These involve tasks that require the user to acquire both overview information such as location and distance of hotels and customer site, as well as detail information such as bridges and tunnels on the path between these locations. Small displays showing only a single view require the user to repeatedly zoom in and out in order to acquire both types of information. To avoid that navigation overload, several visualization techniques have been proposed. The most prominent techniques are Overview plus Detail and Fisheye views. Overview plus Detail visualizations use two distinct views, one showing a close-up and the other showing the entire document. The drawback of this approach is that it requires users to visually switch back and forth between the two distinct views and to reorient themselves every time they do it. Fisheye views avoid the distinction between two views by keeping adjacent information together. The switching between detail region and periphery is thereby accelerated. The downside of this approach is that it introduces distortion, which makes photographic content difficult to recognize. Focus plus context screens combine the best of both visualization techniques and avoid the drawbacks. The main idea behind focus plus context screens is to enlarge the overview portion of an overview plus detail visualization until objects in that area reach the same scale as objects in the focus region. Once this is done, the detail view is placed back into the overview, resulting in a single continuous plane. Since the magnification of the overview was accomplished by scaling its pixels, the overall number of pixels remains unchanged. Focus plus context screens are applicable to practically all tasks that currently use overviews, fisheye views, or simply zooming. The fact that they provide a single, non-distorted view is expected to make them faster to use than overview plus detail, as well as more intuitive than fisheye views.